This video is for Lesson 5, Domain Range, Intercepts, Vertex, and Extrema. Okay, the objective today is I can label domain range, intercepts, vertex, extrema on a graph. These are some of the words that we'll be talking about today: interval notation, domain range, x-intercept, y-intercept, vertex, extrema, max, and min. Okay, let's talk about interval notation. Interval notation, in the past, you have seen things written like x is greater than 3, meaning that there would be an open dot, 1, 2, 3 here at 3, and the arrow would move along the x-axis this way, okay? Or you may have seen x is less than or equal to -2. You would have had a graph like this at -2. You would have had a dot, this is 0 by the way, and your arrow would have moved to the left. Okay, let me mark 0 in there. Okay, so that's the way we've done it in the past. Now, interval notation means the same thing, but we're going to compact it. So, if you see a bracket, or you might see the word or in a parenthesis, you may see those. So let's do this. If you see a bracket, if you see brackets here like this, you would use a closed dot. Let's make sure we write that. If we have parentheses, just parentheses, only open dot, okay? Sometimes we might see the word or, sometimes we might see the word and in our interval notation. This means infinity. It's going to go on forever and ever. Range are all the y values, and domain are all of the x values. We're going to be using those, okay, as we move along. Okay? All right. Domain and range. Again, domain, looking here, domain is along the horizontal. It is all the x values moving both directions. However, like this one, sometimes you have a closed dot. That would mean a bracket there, okay? Range is the up and down. This, oh, by the way, if it goes on forever and ever, this would be a parenthesis. Okay, if you see a dot here again on the range, it would be a bracket. Going on down here forever and ever would be to infinity. That would be a parenthesis, okay? This is infinity. Infinity will always get a parenthesis. Just make a note of that, okay? All right. Okay, domain. What are the x values? Okay, I'm only looking along the x values. I don't care how high up and low it goes. We're only looking on the x-axis. Okay, this is an open dot at -3. So it starts at -3. So let's read the graph. Read graph from the left to the right. Okay? All right, so -3. So we're using everything here at -3. And then let's see how wide the graph. It's going along, going along, going along, going along, and it stops right here. It is only this wide. Notice that I'm going to go through that point. So we are only using these x values. I don't care how high or low it goes. I just care about how wide it is. Think about the width. Okay, so it's going from -3 to 1. Now, if it is an open dot, remember an open dot gets a parenthesis. So we're going to put a parenthesis at -3 because there's an open dot there. Okay. At -1, we have a closed dot. Remember, if you have a closed dot, you're going to be using a bracket. This is interval notation. This is the same thing of saying -x is between -3 because it is an open dot, less than, but greater than or equal to 1. This is another way to write it. This is preferably the way we want you to be writing things now. So that they're in a simpler form to read here, okay? Okay, domain, what are the x values? Again, I want you to assume that this one's going on forever. If there's not a definite dot on these pictures, we're going to assume that they're going to go on forever. So this one is traveling to infinity, and all of these x values are going to the right, which means these are going out to positive infinity. So this is positive infinity. You're like, but it's going down. No, going down, then that means you're looking at the y values. This is still going on and on and on in this direction, which means I'm still using all of these x values out here. This is going on forever and ever. So where does it start? Okay, we're going to say that this is -5 right here. So we're going to say -5.5, and it's going to infinity. Remember, infinity will always get the parenthesis. This is a closed dot. We don't see an open dot, so we're going to assume it's closed. So there's our domain. Our domain again is from, this is a bracket, by the way, is at 5.5 to infinity. Infinity always gets a parenthesis. Okay, how wide is this going? How wide? You have to think about it. It's still continuing up. Oh, did a little cross there. But these x values are going on and on forever. As this one goes up, these x values, I keep going down to the wrong spot there, they keep going on forever. These x values are going on and on forever to the left side. So these are going what direction? Infinity. These are going what direction? Negative infinity. So the x values are negative infinity to positive infinity. And sorry, I started on the right side of the graph rather than left looking at it. I'll make sure that I'm doing better attention to that. Okay, range. Okay, so range is the y values. It's how high it's going to go. So how high is this going? Well, it's only going to this high. How low does it go? It's going to this low. So my highest point on the y-axis is 0. My lowest point that it's touching right here, let me get a better line here, is at -4. So always put your least number first, then your greatest number second. So it is closed dot here at -4. Y value, it is touching and going through. It continues. It just barely touches and out the other side. We're going to do a parenthesis there. That is the range on the y values. Okay? All right, let's take a look at the range here. How high? Well, I'm going to look at this point and draw it like, think about this. Just draw it over to the y-axis till you touch it. Okay, where's that going? 0. That is how high my graph is. It only goes to 0, just to this point. That is as high as it goes. So it's going as high as 0. But where are these y values going? Okay, as I keep going down, now these points you're going to have to draw back to this axis, but where are they going? Well, these just keep going down, 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 down to where? Negative infinity. So 0 is the highest one, negative infinity is the lowest one. Remember, infinity, whether it's positive or negative, gets a parenthesis. Okay, this is a solid dot. We are going to close that up. Okay, now, where are these y values going? We're going to assume that this has an arrow and this has an arrow. Where are these y values? Well, they just keep going up, 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 up to infinity. Where do these y values keep going to? Forever and ever. Negative infinity. So my range is negative infinity to positive infinity. That's how you do that one. All right. What kind of a graph is this? Describe the domain and range. Okay. If you get in your booklet and check your function booklet, this is the shape. It's a V shape, which means it's an absolute value graph. Okay, now describe the domain. Let's do the domain. The domain is the x values. Okay, well, these x values, you're using all these x values. We're going to assume that that's going on forever and this is going on forever. So these x values are going to go positive infinity. These are going to where? Negative infinity. So our domain is negative infinity. Remember, it always gets a parenthesis to positive infinity. Okay, range. Remember, range is how high it goes and how low it goes. Let's start with how low it goes. Here's my lowest point. This is called a vertex. It is touching this graph at -4. So -4. Okay, but these things are going up forever and ever. If you draw from the graph to the y-axis, remember this one's going up forever and ever. So where are these y values going? Whether it's the right side or whether it's the what? Left side, they're going to where? Where's way up here? Infinity. So this is to infinity. Okay. Okay, next one. What kind of a graph is this? Look in your function booklet. This is called a square root. Okay, let's look at the domain. The domain means how wide is it? How wide is this going to be? Well, right here, it's going to 1. So there's our 1. It's going from 1, and we're going to assume that this is a dot. If it was an open dot, we'd know it. So let's put 1, 2, and where are these going in the x direction? Where are these going to? Well, they just keep going to the right, to the right, to the right, right, right. Where's that? Infinity. Very good. And infinity gets a parenthesis. Okay, range. How low does it go? Well, this is our lowest point right here. This is the low point. It is 2. Where are these y values going? Forever and ever and ever and ever and ever. They're going to where? Infinity. Bracket on 2, parenthesis on infinity. All right. X-intercepts are where it crosses the x-axis. Here's an x-intercept. This looks like it's at 3. These are x-intercepts, 2 and -4. X-intercepts is where it crosses the x-axis. Okay, y-intercepts is where is it crossing the y-intercept? Well, it's crossing right here in this picture at -3. That's the intercept. Right here, it's going to be at 2. Right here, it's going to be at -2. That's the y-intercept. Okay, how do you find where it crosses the x-axis? Set y to 0 and then solve for x. How do you find where it crosses the y-axis? Set x equals 0, solve for y. Okay, these would be the coordinate, 0 something. That would be your y-intercept. This one is something 0. That's going to be your x-intercept. Okay, does there have to be an x or y-intercept? Not always. Sometimes you'll only get one of them. In this picture, we've only got where it crosses at 4, so we could say 0, 4. We've only got a y-intercept. Here, we've got a y-intercept here, so this would be at 0, -5, and that's the only thing we've got. Okay, here we don't have anything, so there's no x-intercept, there's no y-intercept. Okay, so it just depends on what the graph looks like. Okay, fancy name for max or min, okay, is called the vertex point. Okay, the vertex point is the lowest or highest point on a graph and we can say it like that. That's probably the simplest way. Okay, so let's look at this one. Okay, we have this quadratic. This is a quadratic or a parabola. The lowest point is right here. So this point, back 1, down -2. So this is -1, -2. That is the vertex. Okay, the lowest point here, because it's opening up, is right here. 1, 2, 3. This is going to be 3, 0. That is the vertex. Right here, we're going to go over 2, up 3. So this is the vertex. 2, 3 is the vertex. Okay. Okay, minimums. Minimums are, the graph is going to open up like this one. It opens up. Okay, remember a min or max is another name for a vertex. Okay, however, this coordinate here is going to be -1 down 4, so -1 down 4. So the coordinate here is -1, -4. But the min, you use the y coordinate of the vertex, is -4. This is your min. Okay? Now, sometimes they say, what's the min? You just say -4. This one right here, this is going to be your minimum. It is 0, -3. Okay, so the min is going to be y equals -3. Okay, always use the y part of the vertex. Okay, this vertex is -2, 5? -2, 5. And the min is going to be y equals 5. You use this y part of the coordinate. Okay, to show min or max. Okay, that's a max. Okay, this one is peaked out here. The graph goes up, hits this peak and down. So this is 1, 2, 3. So this is 0, 8. This is going to be a max because it peaked out. So y is 8. Okay. Oh, and this wasn't a min. Goodness gracious. Okay, hang on. Made a little mistake here. This isn't a min. Excuse me. I was in the min mode when I did this problem. This is a max because it peaks out. Excuse me. This one is a max. This is its highest point on the graph, -2, -1. Even though it's going down the different direction, this is the highest point. Right here is the high point. So y equals -1. This is its max. Okay? All right, and so on and so forth, okay? All right. Okay, what is the vertex? Is this a min or a max? Okay, this one has a low point, so therefore it is a min. Its vertex is at 0, no, excuse me, let's redo this, at +4, 0. Sorry about that. Okay, this is a min, low point, at 0, 0. Okay, this has a min right here. This is the min right here. But there is no vertex, but you can say it bottoms out here. Even though it's flat right here, it's going to flat, the min is y equals -1. That would be your min. Okay? All right, this one right here peaks out at 4, it looks like 4, 2. 4, 2. This is going to be a max. Okay, vertex is at 4, 2. Okay, this one, there is no vertex. And because it's a line. And let's see. On this one, let's back up here, there's no vertex. But we can say there is a min at -1. Okay, let's do this one. This one is 4, 2. That is the vertex. This is a min. Okay, this is a vertex. It's opening down. This is a max. Okay. Let's go with -3 and 0. Okay. And this one has no min, no max. Maybe I better put right here no min, no max, because it goes on forever and ever. Okay. No vertex. Okay, this one has no vertex, no min, no max. Okay, this one has a vertex here and a vertex here. So we're going to call this first vertex 1, 1. And we're going to call the next one 3, 3. And it has a min. This is a min because this is as low as it goes. Okay? Okay, this is your class activity. Work with your teacher to get your domain and range, fill in the XY intercepts, and anything else that they want you to do. Okay, finish your worksheet, turn it in by the end of the class. Okay, make sure your notes are completed. Thank you.